Hello everyone, how are you? Today my group and I will present you a problem with all the stuff that we have learned at the beginning of the school year. Uniform linear movement. The members of my group are Isadora Lagos, Rafaela Sanzeviteri, Jaime Avilés, and myself, Eliana Lizalde. We work very hard on this project.
Christina and Samuel are tickets playing at the local park. Christina started jogging at 1/4 of a minute before Samuel at 2 kilometers per hour. On the other hand, Samuel is riding on top of a scooter at 13 kilometers per hour. These kids are heading towards each other on the 13-meter long trail. At what time do they meet and how much distance do they roam until they meet? According to the stipulated problem, we have to find two incognitas: the time when Christina and Samuel meet and how far along the trail they were when they met. In order to do that, we have to use three formulas: rate equal distance multiplied by time, distance equal rate multiplied by time, and time equal rate multiplied by distance.
We use the rate formula to convert their speed in meters to speed in seconds. Doing that, we're able to continue since all time in the same measurement. Once that is done, we use the time formula to unravel the first incognito. At what time do Christina and Samuel meet? Following that, we must use the distance formula to discover the second incognito. How much distance do they roam until they meet?
Now, it's time to replace the expressions to form equations. First off, rate. We must convert time from an hour measurement to a second measurement. First, it's important to know a kilometer has 1,000 meters, and an hour has 3,600 seconds. By following the formula, Christina's rate is 0.56 meters over seconds. Paul Samuel's rate is 13.61 meters over seconds. Now distance. As you can see, Samuel and Christina have a slight variable. Why are we subtracting 15 from Samuel? Well, it's pretty easy. We're going to start measurement from Samuel's perception, and the problem states Samuel started 15 seconds after Christina, so those seconds must be subtracted. The next step is to answer the second incognito, time. By following the formula, the meeting time is 20.18 seconds. We get this result by using the distributive property, with the number 13.61 multiplied by t and multiplied by minus 15. Finally, we have time and rate. To be able to determine distance, by adding Christina's rate, 0.56 meters over seconds, we know she roamed 11.30 meters before crashing someone. And by adding Samuel's rate, 13.61 meters over seconds, to his distance, we know he roamed 18.70 meters before crashing with Christina.
Yes, Lee, let's review everything that was explained. In order to understand the problem, you must ask yourself, what are they asking me to find? In this case, the time when Christina and Samuel meet and how far along the trail were they when they met. To obtain result, you must follow the formula explained from the beginning. Rate equal distance per time. Distance equal rates per time. Time equal rates per distance. By distributing those expressions to equation, you will obtain your results, but you have to be careful. With the problem is that sometimes it is asking you to shift the measurement to others, like in this problem, where we need to convert hours into seconds to be able to continue. That is known as the conversion factor. It's also important to understand the property and when to use them, like in this problem. When we were working the time formula out, we used this distributive property by multiplying what was outside of the parentheses individually with the variable and with the term inside. I hope you enjoyed about learning a bit more about expression, conversion, equation, and property. Thank you for the watching.